Let us consider these two salts, sodium carbonate salt, copper sulfate salt. So let us consider the solution of these two salts. Here, sodium carbonate has the pH more than 7, whereas copper sulfate, it has the pH less than 7. Less than 7. Now what do you call this one? This is since it is in the alkaline range, it can be called a basic salt. And this is an acidic salt because it has got the lower pH, less than 7. So this is basic salt and this is acidic salt. Next, define pH scale. Define pH scale. Draw a figure showing variation of pH with change in concentration. With change in concentration of H plus and OH minus ions. pH scale is used to measure hydrogen ion concentration. Or hydronium ion concentration. In a solution. It is given by pH is equal to negative logarithm of hydrogen ion concentration, H plus concentration. Or it is also equal to negative log of hydronium ion concentration. Let us draw the pH scale. Let me consider this is the pH scale with the 0 as the starting and 14 is the higher pH. So towards left, this is the neutral. Towards left, acidic nature increases. Towards right, basic nature increases. So acidic nature means that is H plus increases. H plus ion concentration increases here. Here OH minus ion concentration increases. If the pH is less than 7, it is acidic solution. If the pH is less than 7, it is acidic. If the pH is greater than 7, it is basic. If the pH is equal to 0, it is neutral. Next question. What are olfactory indicators? Olfactory means they give different smell in acidic and basic medium. Different smell in acidic and basic medium. Example: onion, clove, vanilla. Choose strong acid from the following. CH3OH means acetic acid. So carboxylic acid, that is organic acid. Sulfuric acid, H2SO4, H2CO3, carbonic acid, nitric acid, HNO3. Here H2CO3, H2SO4 and HNO3, they are strong acids. Carboxylic acid, carbonic acid or weak acids. Next question. Explain the action of dilute hydrochloric acid on the following suitable with suitable chemical equations. That is nitric acid dilute HCl with magnesium ribbon. Dilute HCl with magnesium ribbon. Similarly, dilute HCl with sodium hydroxide. Dilute HCl with crushed eggshells. Crushed eggshells. Now let us consider the first one. Magnesium reacts with HCl aqueous solution to form magnesium chloride MgCl2 with the evolution of hydrogen gas. This is aqueous solution. So you can put 2 HCl. Of course, this is dilute aqueous solution. And then NaOH reacts with the dilute HCl to form sodium chloride and water. Sodium chloride and water. Crushed eggshell is nothing but calcium carbonate. So calcium carbonate, of course, is a solid powder that is dissolved in HCl, dilute HCl, to form CaCl2, CO2 plus H2O. So CaCl2 is the aqueous solution, carbon dioxide is the gas, water is a liquid. So there are 2 moles of HCl. Okay. The blue color of a substance, blue color crystal of a substance. Blue color crystals of a substance on heating in a closed test tube gets changed but the color was regained after some time on cooling. What is that substance? Write down the chemical formula. Explain the phenomenon involved. So what is given here? A blue color. Take down blue color crystals. On heating, it becomes colorless or white. But on exposure to humidity, humidity means moist air. it becomes again blue. You are able to get blue color crystal again. So let me consider the compound A. This is compound B. And again it regains, that is as A. So what is A? What is B? Explain the phenomenon. So this is the question. Now copper sulfate pentahydrate 5H2O. It is blue color crystal. Cyan blue, it's called cyan blue. On heating, it loses water. So it becomes CuSO4 plus 5H2O. So this is white. Then on exposure to humidity, that is moisture, regains its color. So it becomes again CuSO4 5H2O. These water molecules are again trapped. So the compound A is blue crystals of copper sulfate pentahydrate, and B is anhydrous copper sulfate. So anhydrous copper sulfate is white color. Pentahydrate copper sulfate, that is hydrated copper sulfate, is blue color. And this is a typical example of water of crystallization. Okay, it loses the water of crystallization, 5 moles of water of crystallization, and again regains. Okay, so what is the phenomenon? This is the water of crystallization. What happened to this water of crystallization? Crystallization, it loses 5 moles of water and again regains 5 moles of water to become blue color. Next question. Yes, substance X is used. Used as an antacid. It reacts with the HCl to produce gas Y. It is used in fire extinguisher. This gas is used in fire extinguisher. Name the substances X and Y. Write the balanced equation. Sodium carbonate, that is sodium bicarbonate, hydrogen carbonate. Sodium hydrogen carbonate. is used as antacid. It reacts with HCl, NaHCO3 plus HCl, gives carbon dioxide plus NaCl plus H2O. NaHCO3 is a solid, water is a liquid, carbon dioxide is a gas, NaCl is an aqueous solution, water is a liquid. And this carbon dioxide is used as extinguisher, fire extinguisher. So sodium carbonate is X. Sodium bicarbonate. It should be called sodium bicarbonate. And the gas evolved is Y. Find solutions. Next question. Find solutions A, B, C, D. Showed pH as pH 4, 7, 1, 11 and 9 respectively. When tested with an universal universal indicator. Which solution is neutral? Which solution is strongly alkaline? Strongly alkaline. Which is strongly acidic? Which is weakly acidic? And which is weakly alkaline? So which is neutral? 7. So pH 7 is neutral. So B is neutral. Strongly alkaline. So among the highest pH is 11. So 11, that is D, is highly alkaline. Strongly acidic, the lowest pH 1, that is C. Weakly acidic, that is 4, that is A. Weekly basic 9, that is E. That's all. Next question. Write the balanced chemical equations for the following. Bleaching powder is kept open in air. Bleaching powder is kept in air, opened. What could be the reaction? B. Blue crystals of copper sulfate are heated. Chlorine gas is passed through dry slaked lime. This is called slaked lime, calcium hydroxide. D. Carbon dioxide is passed through lime water. E. Sodium hydroxide solution is heated with zinc granules. Sodium hydroxide solution is heated with zinc granules. Now let us write down the reactions for these chemical reactions, equations for these chemical reactions. A. Bleaching powder is nothing but calcium oxychloride, CaOCl2. That reacts with air. So it reacts carbon dioxide present in air to give calcium carbonate, and chlorine is evolved, and that kills the germs. And that is why we apply this bleaching powder in toilet and bathrooms. And this is the balanced chemical equation. CaCaO, totally 3. So here also 3. 2 chlorine, 2 chlorine. 1 carbon, 1 carbon. So already balanced. Next one. B. Calcium hydroxide, not calcium hydroxide, copper sulfate, that is blue crystals mean copper sulfate. So you know very well, copper sulfate pentahydrate H2O on heating loses water. So it becomes CuSO4 anhydrous copper sulfate with the removal of 5 moles of water. So this is blue color, this is white color, dirty white. Chlorine passed through slaked lime. Chlorine passed through slaked lime. Chlorine is passed through slaked lime, CaOH twice, to give calcium chloride. Actually not calcium chloride, CaOCl2. Bleaching powder is formed along with water. So bleaching powder is obtained. D. Calcium hydroxide reacts with lime water, means calcium hydroxide, that reacts with carbon dioxide to form calcium carbonate. That is, lime water turns into milky. So CaCO3, calcium hydroxide, plus carbon dioxide. So carbon dioxide gas is passed through that, so that this is a clear solution. It becomes milky. That is because of the insoluble calcium carbonate, CaCO3 plus water. Next, already balanced. Fourth one, sodium hydroxide react with sodium hydroxide react with the zinc, NaOH aqueous solution, react with zinc to form sodium zincate, Na2ZnO2, sodium zincate with the removal of hydrogen. This is called sodium zincate. Okay.